Okay, in this video, we're going to learn a new method for how to find the vertex of a quadratic function. And this method is called partial factoring. So it's just a different way where we can find the vertex of a quadratic. So here we have a quadratic function in standard form. So this is in standard form. With this method, we're not going to switch it to vertex form. That's when we do that completing the square method. We're not going to do that. In this method, we're actually going to do something that looks like this. Okay, so what do I know about this quadratic function? I know that it has a y-intercept at 3. Pretty much that's not it, but that's a big thing that I know. So I know it has a y-intercept right there. I also know from this positive a value that my parabola is going to open up. So maybe it's going to look something like this. Not really sure where the vertex is. So I just know it's going to look maybe like that, or maybe like this. But yeah, we're going to find out. And you know how we're going to do that? We're going to use the property that a parabola is completely symmetrical. So I know that in addition to this point right here at 0, 3, I know it's going to have a point right here at something 3. Because its parabolas are totally symmetrical. So I know it will have a point right across that will have a y value of 3. I'm just not sure what the x value will be, but that's what I'm going to find out. So that's what partial factoring is. It helps us find this point right here. And once we know that point, we already know this point, we're able to find the middle of the parabola. So how do we do that? Well, we know that the y value is 3. So that's what we're going to do first. We're going to set this y value equal to 3. So basically whatever this value is, we're going to make that y. Okay, so now we're going to simplify this expression. And I'm going to do that by moving this 3 to the other side. So I'm going to subtract 3 from both sides. So I'll have 0, 2x squared minus 8x plus 3, and now I'll have that minus 3. So those 3's are going to go away. So I'll have 0 equals 2x squared minus 8x. Okay. Now our next step is we're trying to solve for x, right? Because we want to know what this value over here is. We're trying to find this x value. So to do that, I'm going to factor. It's kind of like finding the roots, same strategy. We're just solving a quadratic equation. So I'm going to common factor. So I see that they're both divisible by 2 and they're both divisible by x. So I'm going to common factor out of 2x. Now what do I have left for my first term? Just an x. What do I have left for my second term? A negative 4. So I've common factored. And now I'm going to set each term, I'm just going to switch colors, so I'm going to set this term and this term equal to 0. So I'm just solving a quadratic equation here. So I've set them each equal to 0. For this one, I'm just going to divide both sides by 2, and now I can see that x is equal to 0. And then for this one, I'm going to add 4 to both sides. So now I can see that x is equal to 4. So I already knew this one, right? Because I see that there is a point at 0, 3. Right, so we subbed in 3 for our y value at the beginning of this question. So we learned that there is a point at 0, 3, which we did already know that. But then we learned a new piece of information, that there's actually a y value of 3 when x is 4. So we just figured that out. So now we know I'm gonna get rid of my question mark. I'll just rewrite this whole point. So now I know this point is at 4, 3. Yeah, so that's no longer a mystery. That's at 4. So now that I know that, so just to recap, I subbed in a 3 originally for y. So I was solving for these two x values. I already knew this one would be a 0, check. Now I know that one is a 4. Okay, so now I'm going to use my knowledge of the fact that parabolas are symmetrical to find the vertex. So I know that the vertex is going to be right in between 0 and 4. So what's right in between 0 and 4? 2. So I know the vertex is going to be, I know my vertex is going to be at 2 something. I don't know what that y value is. But I know my vertex is at 2 because it's going to be right in between the two x values. So how could we find the y value? Well, why don't we go to the original, I didn't mean to erase it. Why don't we go to the original equation and sub our x value in and determine what y would be. Let's do that. I'm just going to shrink that so I can see it still. Okay, so my original equation, y equals 2x squared minus 8x plus 3. And I'm going to sub in 2 for my x value. So y equals 2 bracket 2 squared minus 8 times 2 plus 3. And let's just solve that. So 2 squared is 4 times 2 is 8. 8 times 2 is 16 plus 3. And then we'll have negative 8 plus 3, so negative 5. So now I know that my vertex is at 2, negative 5. So this point right here, now I know is at 2, negative 5. So we didn't put it in vertex form, although we could now, because we know our a value is 2. We know our x value of our vertex is 2, and our y value is 5. So we could put it in vertex form. So this method is called partial factoring, and it just involves using the y-intercept to find another symmetrical point, then using our axis of symmetry to find the x value of the vertex, and then subbing the x value of the vertex back into the original equation to find the y value of the vertex. Just a different strategy than completing the square. So you can do whichever one works for you. It might seem like it just took us a really long time to do that, but as you get quicker with this strategy, you won't have to do like every single step. So, you'll see an equation like 2x squared plus, 12x minus 11. And you'll already know what happens with the minus 11, so you almost can just jump right into right into factoring, and boom, I just found my 2 points. And now I know the vertex is at negative 3. So you can actually get to the vertex really quickly once you practice it a few times the long way, kind of understand what you're doing, and then you can get to it way quicker. Just a heads up, sometimes you'll get an odd number in the middle there. So let's say you had x squared plus 5x minus 1. So you're partial factoring, so you're subbing in a minus 1 for y. Then you're moving the minus 1 over. So the ones go away. So now you're factoring. Factor in x, because that's all they're divisible by. And set each term equal to 0. And we find out that our 2 points are 0 and negative 5. So when we're trying to find the middle of those 2 points, these ones are easy to work with. I know the middle is going to be at 2.5, but let's just say you're struggling and you're like, oh, I don't know where the middle is. A strategy that would always work is to add those two numbers together, so 0 plus -5, and then divide them by 2. Just like finding the average of two numbers. So that's just a way to find the middle of 2 points. Cool. So that is the method of partial factoring to find the vertex.